Well, thanks, gentlemen, for joining us here today. And just to give you the context, I've been mentoring about five University of Toronto students who are uh, working with Professor Brad Bass on a research opportunity program. So they're actually getting credits for this. We've been meeting every Monday from noon till 1, most Mondays, from the end of May until now. What they will be doing is looking at how to incorporate the LID TTT tool into a analysis of the Roy Ivor Student Residential Building, which is located on the University of Toronto Mississauga campus. They won't be doing a full-blown 3D digital twin, but they have been mentored by Rajesh Dulal. He has just been hired recently by the City of Kingston's planning department, and he's been tasked to look at how to combine GIS and building information modeling to design a retrofit of a building. And he's going to use the same building, Roy Ivor Student Building, and I think he's using CityWorks. The students have looked at using City Engine, and Rajesh is going to demonstrate how you can do LID modeling on this building, but it won't include the actual information from the LID TTT tool. So that's what we're looking for today. So maybe we can go through the questions. You've got the questions, so maybe where do we start, Steve? Who wants to kick this off?
Let's pass the conch to Phil and James to give an overview of the modeling they've looked into for their blue roof at CVC's office, and then Eustace and I will address the question specifically on the TTT, and then we'll acknowledge our limitations on
Yeah,
the monitoring software, the Heisters.
right.
Okay, so over to Phil.
Sure. So, with our blue roof, Jonathan, I don't know if you've actually been in for a tour or not to see it, but it's been in
Not yet.
operation for the past 2 years. You're welcome to come out anytime you want to see
Oh,
it.
yeah. Great.
And what we were doing is we were looking at a few different situations where we wanted to understand when you have a certain amount of water ponding on the blue roof and the valves open, let's say they fail open from a power outage or whatever like that, what is that surge of water going to do in terms of the internal drainage infrastructure? Because you have a lot of mechanical joints that aren't really meant for pressurized flow, they're meant more for gravity flow. And we're also going to link it to performance and so on and so forth. But what we found, and we had a meeting with CHI, which are the ones that kind of run
Mhm.
with the PC swim model, to get the proper term. But we did meet with them to talk about it, and we kind of came to the conclusion for the level of detail that we were looking at, the PC swim model wasn't the most appropriate. We needed to look at more like a finite difference model, which they call it a computation fluid dynamics model. Is that correct, James? I mean, CFD
Yeah,
model or something like that?
CFD model. Specifically, one of the reasons why PC Swim wasn't going to work is because you can't actually model vertical pipes with PC Swim. So that was an issue. So we were looking at something a bit more robust in like a finite element analysis
Yeah.
kind of sphere. So yeah, computational fluid dynamics or CFD modeling is what we were looking at.
And I just want to also just make a note here too. I think that we have to distinguish is what the purpose of the model is. The purpose of the modeling that we were looking at was more to inform design, Jonathan, not so much performance, which I think, well, as we move into the LID treatment drain tool, I think that is a much better approach for looking at site, neighborhood, or street neighborhood scale. Um, but we just found that, yeah, when you get into, like James said, vertical pipes, yeah, different flow regimes, we needed something different than the PC swim model. So we've been leaning towards a CFD model. We haven't actually started it yet. We're we need as-built drawings as well that shows the elevations of the pipes, the diameters, where the elbows are, where the constrictions are. So it's going to be a pretty data heavy model.
Yeah.
So once we get the as-built information, then we want to explore the creation of a CFD model that would allow us to trace the flow from the roof through the building, right down the rainwater harvesting tank, out to the municipal system. So I don't know if that's enough detail in terms of what
Well,
the direction we're going with modeling.
yeah. So quick question. Do you have a BIM model of that, of your infrastructure on that building?
A which model?
Building information model like a AutoCAD, a Revit?
Yeah, we do. We have like some of the original CAD drawing. We have the original design drawings for the blue roof. But what was interesting, Jonathan, is that the drawings that we had for tender for construction and what actually got built look completely different because it's a retrofit, because we encountered concealed conditions that we didn't anticipate. So that's why we need an updated as-built drawings in order to proceed.
Yep. No, I get
Yeah.
that. I get that. So sorry, I didn't want to interrupt. Keep going.
That's okay. That's okay. Yeah. No, that was that's what I wanted to say there. Yeah.
Well, Bill, maybe one other thing we can mention is that Afsana has tried to model smart blue roofs with like green roof equivalents in the hydrologic models. And one of the questions that we currently have is how accurate that actually is, because smart blue roofs are active, green roofs are passive. So there are maybe approximations that you can do in other software, but right now it's hard to model an actual smart blue roof.
Yeah. Yeah. And the other thing is, like, one of the reasons to look at Kisters and what they're doing in Germany is that when you start adding time to your 3D models, right, then you can begin to evaluate if you had that building as a digital twin, the inside and the outside, and then the surrounding land cover, or so then you can combine land use and land cover at that local level, right? And then ideally you'd be able to scale down using gridded data to connect up what the architect, engineer, construction firms are doing on that as built or rebuilt, and the modeling you're doing to protect the assets against what will happen when they start to interact with the natural environment, the land cover. Does that make sense, Steve?
Yeah, yeah. For what I was following you there, mostly. Yeah, yeah. Um,
So what Kisters is doing with the municipality of Aachen is it's mainly around their wastewater system and then also dynamics for transportation. It's the biggest application of the predictive analytics is with mobility and transportation, not so much with water and how water flows in a 2D model, right? So when it leaves the creeks and starts interacting with the built infrastructure, like Corey explained to me, he uses like a 5 square meter cell in the PC Swim to do a two-dimensional model of the how the water behaves in those cells outside of the creeks. And more importantly, he said the LID shines by not sort of retaining the water, but how the water then returns back in to replenishes the groundwater and avoids soil erosion when it, comes back into the creeks, that kind of stuff. Does that make sense?
yeah,
So you
yeah.
have
So I honestly think, sorry, respectfully, Jonathan, so you, that is the third part, right? So we want to get
Yeah.
into the Kisters discussion, but acknowledge our limitations.
Yeah.
I
Yeah.
do, when I read all of that, I'm like, okay, I see what you're trying to do in this whole integrated modeling effort. It's definitely beyond standard practice
Exactly.
for
Yeah.
the students to realize that
Yeah.
you
Yeah.
don't do
Yeah.
that when you're you don't do these things when you're designing. But
Yeah.
this is applied research to take back to things like Bill and James are doing with ongoing R&D work with the blue roof at their office,
Yeah.
right? Is to
Yeah.
optimize the performance of the roof and operation steps and some automated logic, things like
Exactly.
that,
Yeah.
right?
Yeah.
But just to be clear, like as soon as I read it, I was like, oh, this is an interesting academic research
Yeah. Yeah. Yeah.
exercise.
Yeah.
But we've never explored yet tapping into, when I do think of kisters, I still think of like real time monitoring, right?
Yeah. Yeah.
And and then, you know, it seems like your project statement or your challenge is to look at future scenarios too, right? So there's a little bit of a disconnect. You'd have to assume monitoring data that you are looking at or have collected still represents future scenarios. Um, we usually use, in the context of that monitoring data, we use it to calibrate a model, right?
That's the
So
key. That's the key.
for flood control, you're looking at the major storms and looking at, in the receiving water, what are the tailwater conditions? But
Yep.
you don't necessarily need a real time series uh, scenario to model the worst case, right? You just need that
Yep.
higher water level, and that's typically what's done.
Yep.
And it is conservative, right? But in fairness, with real time monitoring data, you're dealing with fluctuations in the water level, and
Yeah.
that might
Yeah.
build some more room in the design. But the high water level builds in the resilience of the design because you're
Yeah.
always assuming
Yeah. Yeah. Yeah.
worst
Exactly.
case scenario. Yeah.
Yeah. No,
So
I
maybe
hear what
that,
you're saying. I hear what you're
yeah.
saying, and I totally agree with you. The problem is that Esri and Autodesk, I went to a workshop and they just use digital twin every second sentence to talk about the merging between GIS and BIM and automating that on the back end. To me, it sounded like snake oil.
Right.
So let's start somewhere small. And yeah, let's just start somewhere small and see how we can connect up the multi modeling levels and then what the architect engineers are doing on the design phase and have the capacity to calibrate what needs to be built in that local infrastructure, given what the tradespeople have actually constructed based on the same blueprint. Because to your point, they might put the anchor bolts in, but it's slightly off because of the way that they built on that terrain or whatever, right?
Mm.
And then if the person fabricating the metal joist, because I know this from personally talking to the guy that does it, he's saying, I want to measure it twice and cut it once. I don't want to cut it and then send it out to the site and they can't install it because it's off. The anchor bolts are not on
Mm.
up to they're out by a millimeter or three whatever, and they can't install it. That's a huge backup in scheduling time and cost on materials. So he bought a robotic total station that he doesn't know how to use. So I got Jeff Moxley to train his 8 students who took the e-learning course from Hitzi, the company from Germany that operates or sold them the robotic total station, 50,000 bucks. And then he showed the students did it and then showed the guy that owns it, here's how you could use it in your business.
Mm.
And here's students that you can hire because they've done the training. So I know you guys aren't there yet, but I'm going to figure out what are the next steps, like what James is doing there. And then how do you build it to spec, right? So whatever sensors, and I know Darko's doing that. Like, let's get the cheapest materials, the cheapest sensors that meet the Ontario building code. And then how do we track that? And I guess Kisters is they're saying, you leave that to us. We'll do that in our data center in Aachen with DataSphere. You just model. You just do your work.
Mm.
That's their sales pitch. Okay, I
So
got us off on a track. Let's go
yeah,
back on track.
let me help us get back on. So
Okay,
I'm going to share my screen,
good.
and Eustace and I will talk to this. So you had a few questions, making sure I'm sharing the right thing. Hopefully everybody sees this. So
Comment.
this is what you put in your email,
Yeah, good.
and relating to the treatment train tool. But respectfully, I'll just acknowledge this could be the treatment train tool, or responses could be the treatment train tool. It could be any other EPA swim based or frankly other type of stormwater management modeling tool.
Okay.
Okay, so
Yeah.
we are the keepers of the treatment train tool still, providing training, providing paced R&D based on the limited resources and funding we have, but we
Yeah.
still are on a new project updating the tool, which is going to carry into 2027 that Eustace is leading, and I'm providing some technical and emotional support, right, Eustace? um,
Love
but
it.
yeah, like so I'll just start straight up that I mean you were acknowledging in a detailed way how can the modelers look at your future case scenarios, including the accessory development units, if I have the
Yeah.
acronym
Yeah.
correct, right?
Yeah.
So second residence or
Yeah.
type housing
Additional
units on a
residential
property.
units. Yeah. Yeah.
Additional residential units. Thank you, or development units. Okay, and you essentially with all of these types of tools can upload uh, GIS shapes, CAD drawings, different different web-based map services that provide by Esri or other, right? And
Yeah.
you can kind of in the TTT you can bring those layers in, right?
Yeah.
And similarly with the watershed boundaries, right? So you can do that and then kind of just have that in play as you're looking at your new development subcatchments and designing accordingly. And then simply for the third answer, um, with the additional dwelling units, how do you model impervious surface impact? Well, I think you would iterate and have different post-development design scenarios, and you're redefining the hydrologic characteristics based on your different scenarios, including these ADUs, and then running the model, and you're getting the predicted or the computational outcomes, right? Both
Yeah.
for peak flows, for water balance, for water quality control, and that will translate to the impact things you're looking at. Now that leads us to this translation too with keysters, and like I was saying earlier, the TTT we don't have optimization routines built into it, but PC Swim does, as another model example that I'm well aware of. And I mean, if you were trying to communicate to this web-based monitoring information, you heard from Phil and James earlier that they explored PC Swim and Computational Hydraulics International (CHI) weighed in directly saying we're not the model for you for what you want to do, but
Yeah.
maybe they are the model for what you want to do, Jonathan, with your team in terms of looking at the Kisters monitoring data. Because I mean, Eustace, I'll give Eustace a turn to chime in and pass the content to him, not to put too much
No, that's
put him on
great.
the spot
Thanks.
too much.
Thanks.
But yeah, but the TTT is limited in terms of, in my opinion, the connection. I'm not saying anything's possible or feasible to program the connection if you have the time, resources, and expertise. So I could see a team maybe working in Python and trying to bridge the gap between the two models and having them communicate both ways.
Yeah.
But I know too much to be dangerous, and I know PC, like different commercial software like PC Swim have built-in routines to optimize using monitoring data.
Yeah.
And with
Yeah.
the TTT, we don't have that. We upload time series data, precipitation and temperature, but that's a limitation. So,
Yeah.
Eustace, do you have anything more to say on that note?
Sure. In terms of, yes, okay. I know you've also, I think, left a voicemail, Jonathan, regarding the treatment train tool and its comparison to Swim. So if you think about Swim 5, that's the free to use engine that we've put in the treatment train tool that also exists in PC Swim. PC Swim is you pay for the license because it has additional tools, additional GIS tools, and so forth. in the tree, and it's a bit more, you could do more complex analysis than what is available from the stock free Swim 5 engine. The treatment train tool takes another perspective. Instead of going and adding on additional analyses, it takes the core functionalities and simplifies it. Still gives you a GIS, but doesn't allow you to do all these velocity analyses and
Yeah.
graphs.
Yeah.
So we're allowed to do, we can keep it for free. So that's the main thing. It's a great tool for teaching. So a lot of our, we find a lot of university professors use it in their courses. The other thing that we added to the treatment train tool is its focus on LIDs. So it's not, for just engineers, but also landscape ecologists, landscape planners, architects, and site planners, property managers to see what are their options for LID types and how much is it going to cost.
Perfect.
So the LID, the way I pitch it is it's a great way to test your site targets. If you have site targets for quantity control, quality control, you can abstract a little bit. You don't really think about how much water is coming onto the site. You're just looking at your site as your site. Then you can play around and showcase which LIDs can I put where, how much is going to cost, and do I meet the target? So I'm going to quickly show you an example if you're interested. Do you
Yeah,
want to see
yeah,
it?
yeah. And you're going down the exact rabbit hole I would expect you to go down because
Okay.
that's perfect. I can link that up to a local developer who's getting into ADUs and he doesn't know anything about the GIS tools, but he's all excited.
It's a
Oh,
case
you can map
study
all this.
of a
Yeah,
hospital
go ahead.
or health
Good.
center. Yeah.
Yeah.
Okay. So this is what we did with the treatment train tool for a healthcare facility. So that's their site. And they wanted to see what are their options for putting in LIDs. So I'm going
Perfect.
to skip all the way to the end because we wanted to do uh, a little bit more, you know, eh, less conceptual and as much concrete as we can. So we took LiDAR and we developed the flow paths. Now, the difference between the data available when we first started the treatment train tool, to do this, you would have to fly a drone, and it's going to be very expensive. Now it's freely available. So
Yeah.
you get this LiDAR data that is already out there free of charge. So we developed the flow paths that also look at not only the rooftops, but also the land cover that we were interested in. And we mapped the outfalls. We also looked at the detailed site rendering to see where the catch basins were. And we said, what if we didn't change the site too much? We didn't do grading differences and whatnot. Based on where the water is flowing, we're going to put LIDs
Yeah.
when we're going to work towards meeting a target, stormwater quantity and quality target.
Yeah.
And then we'll give you a few options of what it's going to cost you, right? So based on this analysis, GIS analysis, we broke down the site into subcatchments and proposed we didn't do too many iterations just based on the contract, but we knew roughly which one LIDs are expensive and which ones are the best bang for the buck, right? So the swales are the cheapest, permeable pavements are the most expensive for the amount of areas you're treating. And then we just directed the water, sized it until we are able to meet our targets. We were slightly under meeting our targets because again, we didn't want to change up the landscape. We didn't want to take up new parking spots. So that's still possible for the client if they like that. And then we're able to churn out the results, both annual average results. So if you care about your infiltration amounts on an annual basis, evapotranspiration on an annual basis, but also your peak flows on an event-based analysis. So you can do both. For the same design, you can look at your 5-year run versus your return period storms, 2 to 100.
Yep.
And then the beauty of it, as I mentioned, is we also get that cost. So how do we get the cost? We have, do I have yeah, there we go. So we get the total cost of implementation with the 25-year maintenance cost. we have a tool, LID, life cycle costing tool. And so that takes in every single labor cost and equipment cost to put these in and to maintain it. You can itemize it. You could use that, right, to do the
Yep.
costing. But what we've done is we've done costing curves using that tool. So we basically size a bioretention. We get the cost, we make it slightly bigger. We find the cost, we make it slightly bigger, get the cost. So we have this curve for
Yep.
cost to area. Then we use that equation in the treatment train tool automatically. So when you're drawing, you get the area, you use the curve equation, and you get the cost. From
Right.
our analysis, the cost is about plus or minus 20%, which is perfect for, your first level of analysis of saying, okay, on a ballpark, what is it going to cost us to put in a bioretention? And then which one are we going to do first is kind of the question we always get from
Yeah.
folks who are looking at it. But
Yeah.
that's the site level. Now, how do we connect this to the watershed scale? At the watershed planning level, what we're doing is those are different models. So as an example model, we use the SWOT. They're different resolution.
What's SWOT? I mean, I know what
SWOT,
SWOT means, but
a soil, water, and assessment tool.
got it. Thank you.
Okay, so it's one of those models that can be done at a larger scale, at the watershed scale, and we do scenario management for the various watersheds that we have. As
Yeah.
one of the scenarios, we say, what if we capture, um, you know, 90% of the 90th percentile storm, right?
Hmm. Yeah.
From all impervious cover. So we have the capacity to capture that volume from all impervious cover. And then we have another scenario that says, what if we capture half of it? So based on those scenarios, we have an output of this is what's going to happen on average over the years if you add additional capture, right? And so now that we have those targets, we can go in and see which or uh, where can you make the greatest impact? So, you're capturing the target here on the east side and on the west side, but if you on the East Humber, if you capture it, especially in this subcatchment, you're making a very large impact on that outfall that's problematic. So
Yep.
it's a little bit of a prioritization exercise that we need to do. We find the area. Now that we have the area and the target, we can go to the treatment train tool and say, we have a target for this site, right? This is going to make an X impact on the watershed scale or sub-watershed scale. Let's plan an LID retrofit, right? So that's the idea of using those two different models. But we also just use a treatment train tool for sites that, out of interest, want to put in LIDs, not necessarily looking at the big picture or the impact they're having, but just looking at the impact they're having on the site itself.
Okay. So here's a concrete example. I live next to a natural conservation authority, and then my street stormwater dumps into Chris Garrett retention pond. Cost $1 million to build it, and it cost $1.3 million to dredge it 23 years later. So they dredged it all. Now, if I put in a dwelling on my backyard, which I can do, how would I know, or what tools, how could I, as a property owner, say, how am I contributing to sustainability in my neighborhood? Or am I gonna exacerbate a problem and increase the cost to the municipality, which increases my taxes?
Yeah, I think that would come with that higher level modeling. So we
Yeah.
abstract the LID type at that point. We don't care
Yeah.
what LID type. We're just looking at volumes and saying, okay, if these properties together, it's hard to say one property, right? Because you're kind of
Yeah.
jumping
Yeah.
stuff. You can
Yeah.
say this subcatchment, all the properties in here, if they retained X millimeters of water, what is that impact on the pond? What we're
Yeah.
seeing is that those ponds are needed
Oh, yeah.
for
Yeah. Yeah.
right. Those ponds are needed. But to your point, in terms of water quality, in terms of delaying and slowing down the water, that's definitely possible.
Yeah. Yeah. Not to mention invasive species, because Phragmites is just they the culvert is full of Phragmites just like a year later.
Right. Exactly.
Yeah. Okay, so this is very good. So I guess the next step here, James, you're looking at the sort of the hydrology performance inside the building, right?
We want to, yes. Like right now, what we have is we have a rain gauge that tells us how much water we retain on the top of the building. So, in a simple scenario, if we have a storm event and we capture all of it, that's a certain air, like impervious area that we know is not contributing to the downstream flow, isn't contributing to erosion because it's lessening the peak flow rate and all that stuff. We haven't modeled that yet, but that's the principle of the smart blue roof, and that's kind of how we would go about modeling that.
Yeah.
We have Kister's data pertaining to how much we've stored on the roof, how much we're storing in our cistern for reuse in our toilets, and we're also hoping to do some energy modeling too, because if we have a cooling medium like water on our roof, we might actually be able to cool the building through evaporative cooling benefits.
Yeah.
So all this is being collected. We haven't really crunched it in a way that would easily lend itself to your project, but we can talk about it for sure.
Well, I mean, you are sort of, it's like you're building on from the other side of the arch, so to speak, right? Eustace is doing this and you're doing this at the building site.
Mhm.
And we just need the key to make sure the arch stands up. I don't think that's a
Sure.
problem. Um, it's getting there because Eustace, you did it with the hospital, right? So that was a cinch. That was one as-built project, was it not?
This is this is a design, conceptual design that they're considering to use for retrofit. Yeah.
Yeah, exactly.
So
Yeah.
just
Yeah.
so from my understanding, Jonathan, are you looking for that link between like an actual built building and the tool that's you're gonna use to quantify the benefits? Like seems like on one side we've got a design and the treatment train tool, and then on the other side we have a constructed thing without all the benefits quantified. You're looking to have something built and then quantify the benefits with a model. Is that correct or
No,
no?
no, no. What I want to do is figure out how do you consolidate this modeling capacity in a BIM design model by an architect and
Okay.
an engineer. And then if it's an as-built or like a retrofit, that would be in the design phase, not in the build.
Okay.
So you're making
Yeah,
it's
but
going back
I
to Steve saying about, running what if simulations and
yeah.
Justus saying, aligning the parameters to get the performance you want based on those assumptions.
See. So
This
we're going from like design to performance, not construction to performance.
Yeah, because design is the cheapest place to intervene, not in the construction or the operation and maintenance of the life cycle. Then you're
Certainly.
into big costs, real big costs.
this this modeling though, Jonathan, is not the cheapest approach, right? And not the
No.
standard practice. So you have to keep that in mind. So
Oh,
so back
okay.
to
Yeah. Yeah.
yeah, back to Eustace's case study. I think that's the extent of how far you'd want the group to take
Yeah.
designing the blue
Yeah.
roof and showing that you're meeting quantity and quality control requirements
And
and
it's
water
open
balance for the
source
site.
and
Yeah.
professors are using it because it's cheap it's open source, but it's industry standard.
If it's used properly.
Well,
It's
that's the key,
industry
right?
standard. Yeah, yeah.
Yeah, yeah.
But
That's the key
but
though.
yeah, it's an applied research challenge to integrate
Yeah.
Easter's data. But again, I just have to be very clear. That is not standard practice. That is
No, it's
academic, and
not.
that's
Yeah.
R&D. That's evolving optimization of systems and getting more
Yeah.
insight that can feed back into projects
Yeah.
where we're promoting better use of green infrastructure, including blue roofs or
Yeah.
green roofs
Yeah.
or what have you,
Well,
right? But
I call it, you called it applied research. I call it the Trojan horse.
yeah.
So you make sure the
So
generals are in the horse before you roll it
yeah.
up to the castle.
So I mean, we hope. I want to like. I'm going to motion that we kind of talk about maybe next steps for you.
Yeah. Okay.
I do have a hard stop of 4.
Yeah.
So hopefully, those listening today have found this discussion a little helpful to provide insights to inform what you're going to do with your project statement and challenge, and what modeling efforts you know are available, and what we've explored with the Blue Roof that is currently in care and control of this collective research group through James and Phil, and what training and practitioner translation to the TTT looks like that Eustace provided with one case study example, and the opportunity to use that tool because it's open source, but flagging the limitations on what I hear you want to do versus what I know the TTT can and cannot do.
Yeah.
Might that could be a multi-year study, but I'm just trying to keep it
Yeah.
real.
Yeah.
I
Yeah.
don't necessarily see a design team solving that in months, maybe
No.
years.
Yeah.
And nor do we have the time and resource to kind of weigh in and be advisors on that. We'd be
No, no.
interested in hearing the
Yeah.
outcomes and invite you to source the stream and communicate them. But yeah, I just trying to keep it on the level there. So in terms of next steps, Jonathan, for you, do you have what you need from us, or are we good there?
Yeah. Well,
Um,
Liliana is the one that did the training on the STEP site for the LID. And I think she was trying to use that Roy Ivor building. Um, and so let me check with her on Monday. And what I could do, should she be using the Open Swim site if she wants to post a question or?
yeah, that was one of my initial recommendations. I would
Okay.
encourage your team to do that. Yes, right. Um,
Yeah.
sensitive for Eustace's time. We could take outcomes from what you've learned, and we would benefit from them too. But what we say with our LID TTT help desk is we're not there to help teams build the whole model. We're
No,
there
no.
to answer specific questions about the tool,
Yeah.
point you in the right direction. And we tend to ask, so where's your post-development file, your pre-development file? We'll take a look at it, turn that around.
Yeah.
But yeah, like I hope you understand, everybody, that we just can't pivot. We all have work plan priorities and we need funding to get into the weeds with any of this stuff.
Yeah.
Um, yeah, and the intent still is we're providing the resource, we're giving practitioners that conduit, we're listening to questions, answering them, and hoping the resources we provide, including the website, so you can find more on the TTT, including some case studies on the website. I'll let Eustace speak to whether or not that case study he showed this afternoon could be shared. But I see him acknowledging or nodding his head. Perhaps it could be. That could be a reference point for you. But yeah, I
Sure.
just encourage everybody to respect people's times and
Oh, yeah,
time
yeah,
and
yeah.
limitations with
Yeah.
any further input we can provide for your project.
Yeah. So yeah, go ahead, Justus. Can that case study be shared or?
Yep, we could share that with you.
Okay. So why not share that and then I'll run it past the two. We have two presenters. One is Rajesh, who's an engineer and a GIS and data analyst specialist working for the city of Kingston. And he's going to be presenting. I think he's using the Roy Ivor Stadium or student residence as an example. And then the students, we might just be able to say, this is how you could do it, and then here's a use case. And then we could, figure that alignment, and then we would point to the step wiki and that process and promote that as a process rather than what we're doing right now. Does that make sense? And then I'll pitch this to the Minister of Labor for a skills development capital fund grant where we would actually design a regional makerspace in a large building as a retrofit. And then that could be a task in the new year. And then it's up to 200,000 and the province pays 70% and the lead partner and partners cover the 30%.
Hmm.
And I'll be talking to the senior policy analyst in the minister's office on September the 15th, 9:30 to 10, and she's going to walk us through how to line this proposal up. And by then I'll probably have a site located Kingston, or we could do it out of Mississauga. Whoever steps up first, then I'll go with them. And I'm not in this for money. I'm in this for mentoring young people and
Yeah, good
leveraging
for you.
and optimizing existing resources. And also with this AI stuff coming, right? You guys aren't going to be replaced by AI, but you will be replaced by guys like you using AI.
Yeah.
So what's that look like, right? And then how do we create pathways for newcomers and as well as for young people coming up?
Yeah, we're
Okay.
already realizing we have to dabble in AI, whether we like it or not. And
It's
it's good. It's a good phase to be in because it does help simplify some coding or computational or iterative routines. But there's always
yeah,
more to explore when you have the time. So
yeah.
yeah,
I
so
mean, you
sounds
don't
good.
want the
So
gen yeah. Okay, sounds good, right?
yeah, sounds good. I think yeah, this meeting has served its purpose. You have some takeaways from us. Eustace will email
Yeah,
the case study. We'll keep track of where you go with this, Jonathan. So
sure.
if you
Yeah,
feel if the funding comes through or you want to consider including the greater step team, including
yeah,
Eustace's team on the funding proposal, I mean that's a
absolutely.
separate conversation we could have
Yeah.
as
Okay.
advisors. If
Yeah.
there's room in the funding criteria to allow
Yeah.
our agencies to be involved, that would drive more engagement from us because we do
Yeah.
have to justify our time
Yeah.
spent.
Yeah.
But yeah, that's another good takeaway for you. So nice
And
to finally
and
meet you. Hopefully we can meet you in person someday.
well,
But yeah,
I'm gonna give James, you can leave. You got 8 minutes. But James, how do you see this fitting into where like what you're doing at the building level?
I think um, it would be certainly helpful. I mean, right now we're only focusing on what happens inside of our building, but this is kind of part of a broader discussion that kind of follows as a footnote for a lot of what we talk about. Like we have some people come to see the blue roof, and then we talk about the benefits in the building, but then we talk about the street scale. If you had multiple of these working, what
Yeah.
would the benefits be? If you had
Okay.
the
Yeah.
neighborhood scale, where you had
Yeah.
like tens or dozens of blue roofs operating, can you cut back on how much space is needed for stormwater ponds, that kind of thing?
Yeah.
So it seems like your thinking is essentially where we plan to go from a modeling perspective as
Okay.
well. How we plan on doing that is not our priority at the moment, but I think we're kind of the same mind in
Yeah.
how we can quantify the benefit.
Yeah. And stay tuned for the National Housing Day because we're going to try and organize the design challenge like the ones the students have been working on. And then we
Okay.
could showcase some of these connections, right? Especially for the conservation authorities that
Yeah.
had 50% of their, mill rate funding cut. So, but you got to make a pitch to these people that are going to sign the checks.
Always.
Uh, okay, thanks,
Mm.
guys. And yes, it's great
yep.
meeting you.
Yeah. Do
If you
you want to
just
stay
send me
online
that,
for just or sorry, go ahead, Steve,
yeah,
Jonathan.
yeah. Anything else? Any closing
Thank
comments?
you, Jonathan, for your keen interest mentoring others and moving R&D themes forward with LID modeling. So thanks
Yeah,
again.
yeah.
Take care. We'll tune into your next updates.
Okay.
Yeah, and good to
Any,
see you, Steve, too. I
yeah,
haven't seen you in a long time, so I'm glad
yeah.
you're doing well.
Okay. See you later.
Yep.
Nice meeting you,
Take care.
Eustace.
Yep.
Take care. Nice meeting you as well.
I'll record it.